Welcome to clickmyproject.com. This project will lead us to the complete demo of dynamic optimization of multi-attribute resource allocation in self-organizing clouds. Let us see the abstract of our project. A novel cloud architecture, namely self-organizing cloud, is proposed which can connect a large number of desktop computers on the internet by a peer-to-peer network. In SOC, each participating computer acts as both a resource provider and a resource consumer. They operate autonomously for locating nodes with more abundant resource or unique services in the network to offload some of their tasks. Meanwhile, they could construct multiple VM instances for executing tasks submitted from others whenever they have idle resources. We propose an algorithm to optimize the task execution time on a qualified resource node given its preset budget and tolerable quality of service. Let us see the flow of our process. Client submits the task with expected resource and budget. CAN network will be formed in cloud platform. The CAN network will be formed based on the available number of resources and its attributes. The task is submitted as a query formation and it will be submitted to CAN network. The CAN network and then will find an optimized resource selection based on the submitted query with the attributes like resource, weight and budget. Then the task will be executed in the optimized selected resource and the CAN network will be updated. And then the resource will be evaluated using the RAM and CPU usage. Let us see the execution of our process. Open all 4 SOC packages in NetBeans. From SOC1 package, run home1.java. Click on Provider. Here, the virtual memory size, free physical memory and current CPU usage will be calculated and displayed. Click on Dimension Vectors. Here, the capacity vector and resource price vector for all 3 attributes will be computed. Likewise, we have to compute the provider and dimension vectors for all 8 resources. This will be applicable for all 4 packages. You have to repeat it. Here, click on Consumer to consume the resource. Load a task. The task contents will be displayed here. Click on Expected Resource Vector. The expected resources will be computed here. Click on Weight Vector to compute the weight of these attributes. Click on Budget. The budget is 95.4. Click Submit Task with Budget. Click the Task Submission button. Now run P3 Receive Task. Click on Receive Task. The task will be received with user constraints. Here the task ID is this and we receive the user budget. Click on Send Query. Here the query is submitted successfully with the user constraints and budget. Click OK. Here we can see the task is submitted. We are displaying the task ID and the file name that is stored in cloud. Click View CAN. The content addressable network is viewed based on the number of available nodes. Here we are having 8 nodes and it is placed based on its attribute value, CPU and RAM. Click on Available Resources. The available VM for the demand is these things and the available VM within budget is we are having all 8 VMs. Click on Selected Resource. Here the Selected resource is 6. It is based on the least cost. Click on Task Execution. Here the selected VM is VM3. It is based on this port number and we have to run from SOC3 package. Open the resource window and click on Receive Task. The task is received here and click Execute Task. Here the task is executed successfully and it is the PDF conversion, so it is converted into PDF successfully. Just close this PDF and click OK. Send the executed task. Click on Send Executed Task. Click on Receive Output. Here the job is executed successfully and it is received. Click OK. Click on Update CAN to update the content addressable network. It is updated successfully. Click OK. Click on Evaluation. Click on RAM usage for RAM evaluation. Here we are using 8 virtual machines, so the usage of all 8 virtual machines is displayed here as in the CAN network. And click on CPU usage. The CPU usage of all 8 VMs is computed as in the CAN network. Hence, here we achieve the efficient resource allocation by optimizing the resources using the resource attributes and the cost. Hence, in this project, we are utilizing all available VMs efficiently by updating the CAN network, and we are providing the resources with the user satisfied demand with the optimized cost and resources. Thanks for watching.